So let's go through. This is probability. For each question, draw the relevant diagram and find the probabilities. So question 1, Venn diagram, two-way table, and conditional probability. So for this question, for this probability diagram, find probability of A condition or given B. So A given B. Okay, so let's start from this part A. So part A. So to do this part A, right? First of all, we need to remember the formula of conditional probability, which is like this. Probability of A condition B. We have to find out the intersection of the set A and the set B and divide by the probability of the condition. So this is the formula to find the conditional probability, where you remember it. You make these two sets intersect, and then at the bottom you put the probability of B, the condition, put at the bottom. Okay, now to find the probability of A intersect B, A intersect B is basically this region, A intersect B, which is 2 out of the total. Okay, so let us count the total now. 5 plus 2 is 7, 7 plus 3 is 10, 10 plus 4 is 14. So basically the intersection is 2 out of 14. So 2 out of 14. That is the probability of the intersections. Whereas at the bottom, we have to find out the probability of B. Probability of B, you look at set B, we have 2 and 3, altogether 5. 5 out of a total of 14. So 5 over 14. And then we simplify, cut these two straight away actually. So 2 over 5. 2 over 5. So this is based on formula. Based on formula. So if you don't want to use this formula, right, there is another way to do it. So the other way to do it will be, okay, so let's see, if you are not using this formula, okay, the other way to do it is you just look at, I write down, look at set B only. That is first thing. And find probability of A from set B only. So that means it is like this. It is going to be like this. If you look at set B only, it is just 2 and 3. Okay, it's just 2 and 3. So let's say I draw it out. If you look at set B only, we just have 2 and 3 over there. So this is the intersecting region with set A actually. Okay, now find the probability of A from set B only. That means if you look at this set B, right, the probability of A is this part, is the part here. The probability of A, which is 2 out of the total of 5. 2 out of the total of 5. So hence, the answer is 2 over 5, and done. Just like that. Yeah? So we have a total of 5, as you can see. 2 plus 3 is 5. And then the region A takes 2 parts, 2 over 5. You will see we get the same answer. Okay, so it's just different way to do it. So that is for A. Now for B, they give us a two-way tables. So when they give us the two-way tables, so of course, first of all, we have to fill up the table. The table is not complete yet. Okay, so what to fill up is, let's say for example, in this first column, we have 1 and 2. We can add up, we get 3. 1 plus 2, we get 3. So I fill up here with 3. In the second row, 2 plus 2 is 4. So I can find out the value here. So I will put 4 over there. So this is 4. And based on the information 9, I know that something plus 4 is equal to 9. So the something here has to be 5. So this is 5. And based on the last row here, so 3 plus something equal to 9. And the something here must be 6. It must be 6. Okay. So because of that, let's look at the blank here. So it's either 1 plus something equal to 5. So the something here has to be 4. It has to be 4. And at the meantime, you can just double check by looking at the second column. The second column, 4 plus 2 is 6. So it works also. So we fill up the table, and now we can find the probability of A condition B. So let's say I do it here. B. Probability of A condition B. So again, I'm going to go through. Yeah. Okay, so let's continue. Just now, where I'm trying to go through with you is, I'm trying to say that there are two methods again. So the first method is where we use the intersect over the probability of the condition. Okay, so if we are using that method, then we are going to put it like probability of A intersect B divided by probability of B. And after that, we have to find out each of them one by one. We start from probability of A intersect B. So A intersect B is basically this region. As you can see, A is here, B is here. So A intersect B is 1 out of the total of 9. We take the grand total, 1 out of 9. One over 9. At the bottom, we have probability of B. And basically, probability of B is where we look at B itself. B itself has a total of 5. 5 over the grand total of 9. 5 over 9. 5 over 9. This is the probability of B. Okay, so then we can just simplify it. We can cut the denominator up and down. And we end up with 1 over 5. So this is the first way. The second way is we follow back this way. Probability of A condition B. As you can see on the right hand side here. Look at set B only. Okay, let's see how we do it for two-way table. Okay, so second method, probability of A condition B. Look at set B only. So which means we look at row B only. I write down first. Look at row B only. That means you look at this row only. This row is the row with row B. Okay, so and from here, from this row B, we have to find probability of A from row B only. Okay, so that means it's something like this. This is your row B. The probability of A is this one, 1, and out of the total of 5. 1 out of 5. Okay, so then we get the answer, and you will realize the answer is basically same with this method. So both method works here. So it is up to you to decide which method you feel like more comfortable with. Okay, now let's look at question 2. Probability tables. Question 10. A letter is chosen at random from the word happy, and the second letter is chosen from the word hey. List the sample space using a table. Okay, so in order to list the sample space, okay, now we do it here. 10A. So you are going to choose a letter from the word happy, and second letter is chosen from the words hey. Okay, so to list the sample space, that means all the possible outcomes. Okay, now our sample space is going to be so we put it in this way. We use two-way table. So the first way is the happy, HAPPY. So happy, yeah. The second way is HEY. So this is two-way table. I'm using the two-way table. So happy and hey. Okay, then put it like this. Okay, now this is the first letter. Here is the second letter. Okay, now let's say, okay, I don't want the bottom one. Let's buy the one. Okay, the sample space will be like here will be HH. This is going to be, the first letter is A, the second is H, A, H. This is first letter P, second letter H, P, H. This is P, H. This is Y, H. The first letter H, the second letter E, H, E. A, E. P, E. B, E. Y, E. H, Y. A, Y. Then P, Y. And P, Y again. And then the last one is Y, Y. This is how we list the sample space. All the sample space is in the table here, this part. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 sample, 15 outcomes. State the total number of outcomes. So that is going to be 15. And C, find the probability that the two letters chosen will be H then E. H then E, this is the one. Okay, so this one, H then E. Okay, so that means only 1 out of 15. Okay, so I put a mark here. H then E refer to this one only out of 15 of them. Okay, now part 2. The two letters chosen will be the same. The two letters chosen will be the same. Let's say I mark it down with yellow. Same letter. We have HH. We have YY. So these are the only two letters that are same. Okay, HH and YY. So we have only 2 out of 15. So we write the answer as 2 out of 15. And number 3, probability that the two letters chosen will be not the same. If it's not the same, that means it's the opposite result of part 2. So you can use 1 minus the probability of the same. As 1 is the total, so 1 minus 2 over 15, then you get 13 over 15. And this is going to be the probability that the two letters chosen will be not the same. So 13 over 15. So these are the answers. And let's move on. Question 3 then. 3 diagrams. So let's go through the question first. 2 people are selected from a group of 2 females and 3 males without replacement. Use 3 diagrams to find the probability of selecting a female on the first selection, a male on the second selection, given that a female is chosen on the first selection. Okay, so we draw a 3 diagram first. So to draw the 3 diagram, let's put it at the side here. 13. Sorry, question 12. Okay, so our 3 diagrams have to be like this. We break down into male and female. Male and female. This is, we are going to select 2 people. So this is the first people. First people. And then the second people we put afterwards. Okay, so the first people can be male or female. And then we open up again. The second people can be male or female. Male or female. Now we have to fill up with probability on each of the line here. So as you can see, we have 2 female and 3 males. So to get male as the first people, the probability is 3 out of 5. Imagine you have two female and 3 male at the beginning. Okay, so to get male, it is 3 out of 5, out of a total of 5 people. So 3 out of 5. To get female, we have 2 female at the beginning. So the chance is 2 out of 5. When you do 3 diagram, right, make sure the probability that you put on the branches here. So we open up branch into male and female. So make sure the probability will add up to get 1. Okay? Make sure 3/5 plus 2/5 end up with 1. So that will be the correct technique in building up tree diagram. Okay, now let's move on. This side. This side you have to think like this. The first people is male. If the first people is male, right? So it end up with that male has been chosen, has been selected, and we only left out with 2 female and 2 male. Let's compare with this one. Initially there are 3 male. One male has been chosen, so you still have 2 male left. Okay, so based on this sample, now to get male again is 2 out of 4. 2 out of 4. To get female, it is 2 out of 4 also. 2 out of 4. So again, you can see it totaled up to 1. Okay? So likewise, for this one, male and female, if the first people is female, imagine that. If the first people is female, so the female has been, 1 female has been taken away, so you have only 1 left. So for this case, you have only 1 female left and 3 male as well. Okay, so now to get male, 3 out of 4. 3 out of 4. 3 out of 4. To get female, 1 out of 4. Okay, so this is the tree diagrams. The tree diagram is very important because once you have that, then we can answer the questions easily. Okay, like in part A, female on the first selections. First selection, 2/5. And as you can see here, the first is female. And B, a male on the second selection, given that a female is chosen on the first selection. Okay, this is conditional probability. That's it. Male on the second, given that female is the first. Okay, so that means this one. Female is the first, male is the second. So end up with it is 2/5 times 3/4. 2/5 times 3/4. Okay. The first is female, the second is male. So we count this, and then we will get 3/10. 3/10. And let's quickly go through the rest. Two males. 2 males will be the first one. This and this. This is 2 males. So 3/5 times 2/4. Then we will get 3/10. And then D, 1 male. So 1 male will be this one, male and female. This is 1 male. Or female and male. End up with 1 male also. Okay, so we take D, we take this. C, we take this. Okay, so we add up 3/5 times 2/4. Or the other way, 2/5 times 3/4. So this one, let's check with calculator there. 3/5 times 2/4, 2/5 times 3/4. So we get 3/5. And part E, at least 1 female. At least 1 female, that means we can take this, and this. So to make it easy, we can just do like 1 minus the first scenario. 1 minus the first scenario, mu, mu, mu and mu. So 1 minus that. So 1 minus probability of mu and mu. So if we do so, we no need to count the 3 scenarios. We just do 1 minus the first scenario, and we will end up with the same answer actually. So which is 7/10. Okay, so